CES. It was great to be back after a 3-year absence. I haven't attended every year, but my experience goes back to when there was a summer show in Chicago. I bought my first CD there in the 80s. I still have it. Didn't even own a CD player, but was fascinated with the format. I did buy a player within a year. This year it was a working trip for my company, AuraFuturity, and as part of that I visited some of the companies working in the hearing space. With one exception, these are not finished products, but technologies you'll see in the not-too-distant future. In this video, I'll share 5 of those. While this does not represent everyone working on these developments, it does represent what you can expect to see in next-generation devices. One focus was to see the state of machine learning, sometimes referred to as AI-based speech-from-noise extraction technologies, as it applies to in-ear devices. You may have been using some of these advanced forms of noise reduction without even knowing it. For example, it's been available in Microsoft Teams for a couple of years now. They describe it as specially trained deep neural networks to filter out noise and only retain speech. This is fundamentally different from traditional ANC that you'll find in earbuds and key to solving the cocktail party problem. Because the noise in a noisy restaurant or pub consists of other voices, applying ANC to reduce the din also reduces the voices you want to hear. Directional mics and traditional acoustic filtering can only do so much, and we've about hit the limit. The new machine learning techniques can take noise reduction in loud restaurants to a whole new level. The problem to date has been that the software is too large and resource intensive to fit in in-ear processor chips. For example, Whisper hearing aids are getting this done by running their software in a wireless external pod they call the brain that you can put in your pocket. But that is about to change, as you will see. In this video and some of the others, I had the demo playback run through their algorithm afterwards, so you can hear the result just as I did.
Hi, I'm Michael, this is Martin. We are 2 of the co-founders in AugmentedHearing.io. So what we do is we build AI models which we squeeze down. They can fit in earbuds, and then they will enhance speech, meaning it will take a voice out of the noise and make it understandable. So maybe I can show you a little demo. This is just an app, but it's essentially the same model we will build into the earbuds, right?
So you're running the algorithm on the phone right now.
Yes.
And it's actually you're not passing any signals back and forth.
No,
you're
no
just
tricks,
charging your
no
phone,
tricks
right?
here.
So the algorithm's running on the phone, but ultimately you're going to implement it in a DSP for use in an earbud.
Yeah. So if I, for example, if I try this out and I speak here and I know there's lots of noise in the background. So my version of the sort of the thing here with this is with background noise, you know, and there's a lot of babble around us. And if I move into the next one here,
it'll be the denoised version.
This will be the denoised version, but it's not just denoised. What happens is it will say, okay, what is my voice like? And it will enhance the actual speech, you know, the phonemes, the contrast, which makes it possible to understand what's being said.
Okay, so you're actually doing denoising and you're also increasing speech clarity.
Yeah, so we're doing AI voice enhancement. So we've trained on lots of different voices, right? I think we started with 50 million or something like this, but you know, we really come down to parameters which are by now like 1 million parameters, 500,000 parameters, 250,000 parameters. So the model is so small now, trained on voices that you can actually fit it into earbuds, right?
And it works with all ranges of voices.
Yes, because it's come across, when we started, you know, there were some deep bass voices which it had never heard, so it would treat that voice as noise. It would say, I don't know what that is, right?
But now you've got an extensive enough training model, right? Depending on like language, culture, gender, you have no issues with any voices?
So we trained on English, and then Martin spoke Danish to it and had his kid, you know, make a lot of noise with toys, and it came out perfectly. But of course, if we are talking other types of languages, Mandarin, Vietnamese, tonal languages, we will train for that, and we can also train on different types of noises.
So you might have different training models in different regions, in other words.
Yes, and also for different type of purposes. For say, if we work with critical communication like firefighters, police, you have the wee, wee, wee in the background and noises you are not used to maybe normally. So we can cater for these. And what is important is also they work in highly noisy environments, right? So we are talking really very loud environments where we can go in and enhance voices.
Okay, got it. All right, I want to listen to the demo and I can describe what I'm experiencing. So first I'm going to listen to the version without denoising.
Speak here, and I know there's lots of noise.
Okay, and I can hear it. This is Eureka Park, which is amazingly loud, and I could hear all of it. Now I'm doing the enhanced version.
Speak here, and I know there's lots of noise in the background.
Yep, so I'm actually going to try doing it this way. I don't know if it'll work, but...
Speak here, and I know there's lots of noise in the background.
And now the enhanced version.
Speak here, and I know there's lots of noise in the background.
So in listening to this, it actually did a really great job taking care of this noise. The speech intelligibility was really, really good in the enhanced version. When do you actually expect this to be implemented in devices people can buy? What's your timeline?
So we have trials running now with emergency services. We are also having trials with sort of critical communication, firefighters, police, push-to-talk things. And in the next months, we're also running chipsets in earbuds. So it's like an evolving thing where we try and learn, get as much customer feedback as possible to figure out how can we improve this even further.
Okay, excellent. Well, thanks a lot for your time. I appreciate it.
Thanks for having us.
You're welcome. Those working on the software are driving for smaller size and greater efficiency. On the other end, there are companies developing processor chips that will run noise extraction software in a hearable or a hearing aid. Note that this demo by FemtoSense, like others, is working with a single microphone. It does not rely on directional mics.
Well, very nice to meet you, Andy.
Nice to meet you as well.
Thank you. Yeah, so we're here at CES 2023 with FemtoSense. So we are a AI processor, inference processor, software and algorithms company. So our goal is to make AI edge inference far more efficient, faster, and more cost-effective. So you can actually introduce, new artificial intelligence features into things like, hearables, hearing aids, earbuds, ANC devices, and many more. So what we're showcasing here at CES, we have our chip over here. So this is our, it's very small, so you really have to zoom in. But this chip is designed to be able to bring AI capabilities into things like that I just mentioned. So all the hearables, all the hearing aids. What's really been limiting those products from getting the kinds of features that grab headlines is that the processing power is just not there, and it's too power hungry. So you'll burn your battery in like 10 minutes, even if you did want to do AI. Now with our processor, you should be able to run effectively all the time without compromising the battery life. So we're showing the one microphone version of noise cancellation just using the AI processing.
Okay, I want to ask you a question, and that is, in a typical earbud, you have a power budget?
Yes.
And what percentage of the power budget would be consumed by this chip running smart ANC?
Yeah, it's a great question. So the demo we're doing here is about 0.5 milliwatt. So that's 0.5% of a 100 milliwatt battery. And so it's not going to impact the battery life, really.
Yeah, so you can really implement this without a battery life impact. And we're talking about ANC, which I think is a great way to describe it popularly. Mm-hmm. But what you're really doing is speech from noise extraction, correct?
Right, exactly. It's artificial noise, active noise cancellation is ANC, but that really cancels everything. In the real world, not everything is noise. Hopefully, Andy is definitely not noise. Hopefully, I'm not noise. And now using AI, you can really analyze the sound as it's coming in live and say, okay, well, that was cat or dog, or construction, or a fork touching the plate, and so don't let that through. But now if you're a person, let that person through.
Well, and this is a good point because the restaurant or pub noise, for example, consists of other people talking mostly. So yeah. ANC isn't effective because you're trying to suppress in the same bandwidth as the voice of the person you're trying to talk to.
Exactly.
So that's the whole point of the machine learning extraction techniques.
Right, exactly. This is not a new problem. This problem has been around forever. But now it's saying, well, now we have much more powerful tools to tackle this problem. just so long as we can run it efficiently, right? So we help with the efficient part. We also build the reference sort of algorithms, but now these algorithms are really, analyzing the meaning of the signal that's coming in. It's not just, here's a frequency, let it through or don't. It's not like, okay, this is a person across all these frequencies at this time, let this person through, and don't let, maybe somebody in the background through.
Okay, great. All right, so I'm going to try the demo. All right, so I'm going to put the headphones on. This microphone is going to pick up both the room sound and also pub noise, which is going to play through that speaker over there. And this button will turn on the noise extraction.
Yep. Mm-hmm.
All right, let's give it a go.
Well, let's make some noise.
And I have to say, you're not going to experience what I'm experiencing. We'll add that so you can hear it afterwards, but you're going to hear the...
Oh, you hear it now?
Yeah,
all right.
jackhammer sound or truck.
Right? Okay, so now we're not doing any processing, we're just passing through. And now I'm still getting through, but that, I guess, is like a expedition or excursion engine noise is really
Yeah, and I can still hear it, but it's greatly reduced, so the SNR has gone up a lot.
Exactly. And now the truck is back in.
So
I'm sort of shouting over the truck, and now it's so quiet, yeah.
Play the pub sounds. So
okay, so we'll do...
Right, that's the big use case.
Okay, so here, very annoying, we have a cup, tap the table, right?
Yep,
so
people
very
talking,
very
coffee
painful.
shop sounds.
And now I can talk, right? And this cup noise is much, toned down. It's really in the background.
And actually, it does a much better job in a coffee shop than it does on a truck.
Yep.
And which is perfectly fine from my point of view, because the loud restaurant case is really the case you're addressing most of all.
Right. Exactly. So,
but even the SNR was greatly improved on the truck too. Yeah.
Yep.
So that was a really compelling demo. Tell me about the implementation timeline. When do you actually expect products to be on the street incorporating your tech?
Well, that's a great question, Andy. So, as you can see, we do have our chips, and now we are actively engaged with multiple potential customers, doing the evaluations, doing the reference designs, doing the prototypes. We're really targeting and trying to get our partners to have these differentiated AI features, so they can be in time for either Christmas or next CES. And hopefully we'll see you there doing demos with their real products. So
I will be
very
here,
exciting
and I'm
time.
looking forward to it.
Likewise.
Thanks a lot for your time today.
Okay, thank you, Andy.
Another company making chips capable of running machine learning algorithms is GreenWaves, who is enabling software partners to implement their algos on board. At CES, I experienced AuraSound's software demo running on GreenWaves' new GAP9 processor.
Okay, hi Andy. Very good to see you. So I'm Pierre Guiu, I'm CEO of AuraSound. AuraSound is a software provider. We are highly specialized in noise reduction for headphones. And we're here at CES 2023 with our great partner GreenWaves Technologies. GreenWaves developed a new chip that can embed AI type of algorithm for embedded audio. This chip is called GAP9. It's going to be it's been released last year, and it will be on the market this year very soon. And I've got here a demo of one of our algorithms for voice pickup that does AI type of noise reduction.
Okay, so what you really have here is you have an ML noise reduction technique running, and in this demo, you're actually going to apply the noise reduction to the microphones as if you were making a phone call, for example.
Exactly.
Correct?
So we took a headphones on the market with a simple arrangement of two microphones in one cup, and we plugged that into the GAP9 board from GreenWaves and run our ML algorithm for noise reduction.
Got it.
And you can go on and off just to see the difference.
Okay, and so we can turn it on and off here.
That's it.
And you could just as well run this algorithm on the microphones for speech and noise reduction as a hearing enhancement, correct?
Exactly. You can do that as well to enhance face-to-face conversation. When you are, for example, in such a noisy environment, you want to pick up the voice of someone in front of you and enhance that. This is technology that we are called tilled voice first, and we actually patented quite years ago, now in 2015, and now is available on ML type of algorithm.
Boy, 2015 when we first met seems like a very, very long time ago. Okay, so nowhere but CES would you put something like this on your head.
Yeah, we are at CES. So
But we do this
I'm
every
I'm
day.
allowed to do it. Yeah.
And so what we have here is you have an on-off switch, so you can turn the noise reduction algorithm on and off. And then I'm going to take the second pair of headphones, which are where? All right. And I'm going to wear this set.
Okay, so now you step outside of the room and you can hear me talking with my voice being picked up by the microphone and being processed by
And
our
there's a
algorithm.
good-
So it's probably off now, and I will turn it on. So now it's on, and you get my voice with all the background noise filtered out. You probably can't hear the people behind me talking.
It is amazing. It is amazing how well this is working. And so, yeah, so the applications for here would really be twofold. One is clear calls and noise, ability to control your voice assistant, but then also hearing enhancement. When you turn this on when you're in a loud restaurant or pub, you get a high degree of noise reduction, which enables you to hear your mates better.
Okay, so obviously this is a demo, and it will be available in our first product this summer.
Very nice meeting you guys. Yeah.
In the summertime, you said?
In the summertime, we have the first product on the market under the AuraFuturity brand.
Very much looking forward to seeing it. Thanks, Pierre. I appreciate the demo today.
Thanks a lot, Andy.
This is a far from exhaustive list of companies and researchers working on the cocktail party problem with advanced techniques. A lot of work is going on in the background that will explode onto the market before very long. This promises to improve the lives of many people at all levels of hearing loss. As I've pointed out before, Brent Edwards at the NAL identified about 25 million people in the United States alone who do not have audiometric hearing loss, but still have difficulty understanding others. Many of these struggle in noisy situations. Amplification will not help, but devices that remove the noise have real potential. Extrapolating that 25 million on a global basis, that's a lot of people. Plus, of course, better noise reduction will help those up and down the hearing loss spectrum. This will be a real game changer. What you've seen so far will be software installed at the point of manufacturer. There are those working to implement an app store for hearables in the same way we have for phones today. This will separate software developers from the need to create hardware, expanding the innovation pipeline. People will be able to try and buy all kinds of applications for their hearables. As I've written earlier, I have no idea how the FDA and other regulatory agencies will handle it when people can load a third-party hearing aid app months after they buy their earbuds. Two companies are working on this today, Bragi and Sonical. I visited the latter at CES.
Well, hi everyone. My name is Mike Vartanian. I work here at Sonical, and today I'm going to show you the App Store ecosystem that is enabled by Sonical's Cosmos operating system. All right, so what we have here, our setup here consists of a few different parts. We have a tablet, which is kind of functioning as an application or a source for the audio. And over here we have two boards. We have our current chipset that we have our operating system running on. Right now this is an ST part, but Cosmos is a cross-platform operating system, so it will run on many different chips, ARM cores, Hi-Fi cores, etc. Right here we have a BLE development kit from Nordic that is going to be communicating with the tablet to get the apps from the App Store pushed down to the device.
And this is ultimately the silicon that'll run in here, correct?
Yes, yeah. Obviously this one's pretty large right here, but so this one's not actually geared for headphones, but we do have other chipsets that we support that are much smaller that will support.
Okay, so let's
devices.
see the kind of apps you're demonstrating here.
Yep. All right. So this is a simple dashboard that we created.
So ultimately, this would be a consumer-level user interface that would give them the ability to shop in an app store.
Exactly. So many of your OEMs will probably skin it with their own logos on it. Ultimately, we see this as being like a very open app store, independent of OEMs.
Okay, let's see the kind of apps that you've got in here for
Yeah. So right here in our store, we have just kind of a handful of plugins. We have different ones such as spatializers, we have bass boost, personalization, different hearing protection. We have many partners working on many different applications. This is where we really do see the benefit of Headpoint 3.0 is bringing in innovation from many different areas into the ear.
So right now you've got music personalization, you've got a hearing protection app, which is a loudness limiter essentially, correct?
Yep.
And then along the way you could have, somebody could write a speech from noise extraction algorithm.
Exactly.
You could have an OTC hearing aid algorithm, which is doing personalization of the microphones. All this is possible within this operating system. Correct?
Exactly.
Now what you've done is you've democratized access to the ear by allowing lots of different people to innovate with their software without necessarily having to worry about developing the corresponding hardware.
Exactly. You got it.
All right.
What we'll do is we'll go to the store, and our mock store here has some plugins available for us. First thing we'll do is we'll get that hearing protection one. We'll hit the Get It button. So right now this plugin is somewhere in AWS land, and it's coming directly to the tablet via our hotel Wi-Fi connection, and then eventually it's going to be pushed to the actual chip running over BLE. So now if we go back to our main kind of interface, we now see that hearing protection app is loaded. And now we're going to go and we're going to try to download the spatialization. So this is actually a third-party company called Iden Audio that have some really great tech for spatialization, and they've ported their algorithm to our framework.
And so if I were to put the headphones on right now, I would be experiencing the hearing protection app. It's not loud enough in here to make it work, but I would actually have it running on the headset right now because you downloaded it from the App Store. What would you say here is your development timeline here? When do you actually expect to be to market in a headphone that consumers could buy? And that app developers, when will app developers be able to start developing for
So
us?
app developers can start right now, right? So we have about 10 to 15 plugin partners right now that are actively developing their plugins for this. We're talking to hundreds of other plugin developers. So yeah, we're available now. We have an SDK available. We have dev kits available that they can access now. We do anticipate actual end products available sometime this year. They're not going to have an open app store, but that same app store model can actually be employed by an OEM to get to market quicker. Right?
Yeah, so in the first iteration of the product, there'll be a selection of apps that will be available from the ODM itself.
Yep,
And
exactly.
So they can actually have different models based on different features based on the apps that are plugged in.
Yeah, so compared to the current product development lifecycle, they don't actually have to do that porting exercise. If the plugin developers and the end product manufacturer are using the same framework, Cosmos operating system, it's going to literally be a drop-in. Right.
And so that'll run on closed ecosystem basis.
It'll start closed.
But then an open ecosystem like an app store will follow.
That's correct. Yep.
Oh, terrific. Hey, thanks a lot for the demo. I appreciate it.
Oh, thank you.
As processor chips increase in power, they're having a positive effect on people's ability to communicate in other interesting ways. Two companies, X-Ray, that's spelled X-R-A-I, and Xander, that's X-A-N-D-E-R, have developed live transcription software for smart glasses. The glasses themselves are getting increasingly slender so that it's possible to wear them in public without feeling self-conscious. The two companies have different approaches. Xander performs transcription directly into glasses, while X-Ray tethers to a smartphone to add advanced features like live language translation, support for remote mics, and more. I visited Xander to see how it works in one of the noisiest exhibit areas in all of CES, Eureka Park. I was even able to film the glasses in action, but note that the top part of the screen is cut off. The words were visible sooner than you will see here. It still gives you a good idea what it looks like when you're actually wearing the glasses.
All right, I am Alex Westner, co-founder, CEO of Xander, and we are here at CES talking about Xander glasses, which are AR captioning glasses for people with hearing loss, so that as you're having trouble hearing what people are saying, you can see real-time speech bubbles of conversations that are capturing right in your field of view.
And these are standalone glasses? You're not tethered to anything?
The idea for Xander glasses is we are building these as single-feature standalone appliances. So the idea is you take the glasses out of the box, turn on the power button, put them on, and then they just work. So there's no tethering to a phone, no need for a cloud service or data plans or anything like that. It's just on and off appliance. So here we are. You're going to try out the glasses. What do you think? How's that working for you?
Oh, that's working excellently. Even in this noisy environment, the accuracy, it may not be quite 100%, but it's very much enough that I get the context.
There you go. That's great. So
we're on a standalone set of glasses.
Yes.
That's excellent. Now, whose glasses are these?
The glasses are made by Vuzix. They're a company based in New York. So American made, very good company. They've been building glasses for 10 years, and we are building the software for their hardware.
So the glasses are theirs, but the algorithms are your proprietary algorithms, which are allowing the real-time transmission.
So we're licensing their hardware to build our application.
This is amazing.
From Sign Glasses.
Yeah, great.
This is by no means easy, but I wanted you to see
curious,
what it looks like on the screen.
Are you guys doing glasses?
Yes.
Oh, you are? Okay.
Yeah. So
you can see
you had Vuzix glasses in your
picking up my voice from
so we do sign language and
this is sign language for that.
So I'm really impressed. That's amazing. Hey, thanks a lot for showing it to me.
Thanks, Andy.
And good luck.
Appreciate your time. Thank you.
In visiting these companies at CES, I was just scratching the surface of the work being done to bring improved solutions to market for people with hearing difficulty. I've heard people describe the transition from analog to digital hearing aids as having a seismic effect on treatment for hearing loss. As you've seen in these videos, we're now at the brink of the next revolution. It's going to be an exciting time. Thanks for watching.